All right, we're looking at page 190, and we're going to start talking about net force, balanced forces, and unbalanced forces. First of all, the net force on an object is the combination of all the forces acting on an object. And you guys have probably used the word net to refer to like a basketball net, a butterfly net, something like that, but net can also mean total. So, in other words, the total force on an object is the combination of all the forces acting on an object. And the forces can either be balanced or unbalanced. So let's talk about what that means. Balanced forces are a set of forces that cancel one another out so that there's no overall force on the object. And it's very important that you understand that balanced forces do not change the motion of an object. Okay? Now, an object can be moving if balanced forces are acting on it. It's just that object can't be changing how it's moving, and that's a really important distinction. All right, unbalanced forces are a set of forces acting on an object that do not cancel one another out. When forces are unbalanced, the motion of an object changes. Unbalanced forces can make an object start moving, speed up, slow down, or change direction. In other words, unbalanced forces make objects accelerate. Okay? All right, so I wrote out to the side balanced forces and reminded you that that means that the net force on the object is 0. Unbalanced forces, the net force on an object is not 0. All right, on number 9, an object changes direction. Are the forces acting on the object balanced or unbalanced? Explain. I know that the forces are unbalanced because the object accelerates when it changes direction. So if it's changing direction, it's changing how it's moving. That's acceleration. That means that the forces acting on it are unbalanced. Okay? All right, we're going to look down at the bottom at the airplane situation. So hang on just a second. All right, I'm looking at number 10. It says draw arrows showing the strength and the direction of the force exerted by the towing vehicle and the force of friction on the plane. All right, it says the vehicle pushes the plane backwards towards the runway. The forces on the plane are unbalanced, so it moves in the direction of the net force. Okay, I don't like that they put moves in the direction of the net force. You need to scratch out the word moves and replace it with the word accelerates. Because if forces are unbalanced, then the plane is going to accelerate in the direction of the net force. Because the reason I don't like that they use the word move is because objects can be moving when forces are balanced. It's just they're not changing how they're moving. So they really needed to put accelerate. All right, and I notice, or please notice that I put a big arrow pointing to the right for the airplane, a smaller arrow for the friction. Okay? And because the push is bigger than the friction force, we have a net force that's not equal to 0, and the plane will accelerate backwards the way it's being pushed. All right, now I'm on page 191, and I'm looking at the blue heading that says, how is net force calculated? Remember that net force really means total force. Okay, so when two forces act in opposite directions, the smaller force can be subtracted from the larger force to determine the net force. Okay, when two forces act in the same direction, they can be added together to determine the net force. And so let's look at some of the examples that I wrote. At the top, I have a box, and there's a force of 20 newtons acting to push it to the left. There's a force of 10 newtons acting to push it to the right. Okay, 20 minus 10 gives you 10, and the box winds up accelerating to the left because it accelerates in the direction of the bigger force. Okay, so the bigger force wins. Okay, second example, I have maybe somebody pulling to the right with 20 newtons of force and maybe somebody else pushing to the right with 10 newtons of force, but those two forces are acting in the same direction, so I add them together, and that's a total of 30 newtons of force, and it's going to accelerate to the right. Third situation that I drew is, say for instance, somebody's pushing to the right with 10 newtons of force, somebody's pushing to the left with 10 newtons of force. 10 minus 10 is 0. That is a situation where we have balanced forces and no acceleration. Okay, so The first two situations, we have the box accelerating, meaning it's changing the way it's moving. It's either speeding up, slowing down, or changing direction. The third situation, we have no acceleration. Okay? Now, notice I didn't say we have no movement, we just have no acceleration. It's not changing the way it's moving. All right, down at the bottom, number 11. Under Do the Math, it says, imagine a person pushing a chair with a force of 200 newtons. The force of friction that's acting on the chair is 150 newtons in the opposite direction. Complete the following activities. Number 11 says, draw your own sketch of a person pushing a large chair. Draw an arrow to represent each of the forces described above. So let me show you guys my lovely chair drawing. It's really beautiful. So there's my chair. Somebody is attempting to push it to the left. Sorry about that. Somebody's attempting to push it to the left with 200 newtons of force. All right, so here's the situation. I've got the chair. I used an arrow to represent the force of 200 newtons acting towards the left. And it really doesn't matter if I put the arrow here or whether I point it to the left and put it here. It really makes no difference. So 200 newtons to the left. I also need an arrow that's a little bit shorter to represent 150 newtons to the right, and it needs to point obviously in the opposite direction. Okay, so there's your situation for 11. 12 says write the value of the force next to each arrow, and I've already done that. And then 13 says find the net force, meaning find the total force acting on the chair. Well, I am going to subtract them because they're acting in opposite directions. 200 newtons minus 150 newtons gives me 50 newtons. Now, it's going to be 50 newtons acting towards the left because my bigger force was acting towards the left. So that's, it's the bigger force wins out, basically. Okay, I'm now on page 192, where the blue heading says, how do balanced and unbalanced forces affect motion? First of all, velocity is the speed of an object in a particular direction. You've already learned what velocity is, but there's a reminder. And then a little bit further down, it reminds you that acceleration is the rate at which velocity changes in a given amount of time. An object accelerates when it changes its speed, changes its direction, or both. Okay, and this is stuff from lesson 1 that you guys are already familiar with. So an object accelerates when it speeds up, slows down, or changes direction. Okay, and what is acceleration? Acceleration is change in velocity over time, and that can look like speeding up, slowing down, or change in direction. Now, what causes acceleration is an unbalanced force. Okay, so that's what we learned on the previous couple of pages. All right, balanced forces result in constant velocity. All right, so I'm down at the red heading, meaning that there's no acceleration. So when forces are balanced, the combined forces acting on the object will produce a net force of 0. The object has constant velocity. Constant velocity means that the object does not change its speed or direction. It is really, really important that you understand that objects can be moving when the net force is 0, meaning objects can be moving when balanced forces are acting on them. It's just that the objects are not accelerating, and it's really important that you understand that. They can be moving, but they're not going to be changing how they're moving. Okay, so make sure you write that down out to the side as well as underlining and highlighting. All right, I'm now looking at page 193 where it says unbalanced forces result in changing velocity. And I made a little note. Unbalanced forces cause acceleration. When forces are unbalanced, an object will accelerate and show a change in velocity. Okay? Unbalanced forces are what cause acceleration. Okay, and objects are going to accelerate in the direction of the net force. So if the net force acts to the left, then the object will accelerate to the left. I didn't say it moves to the left, but it accelerates to the left. Okay, down at the bottom on number 16 where it says visualize it, I don't really like those two pictures because to me, it's difficult just by looking at a still photograph. It's difficult for me to understand what is happening to the ball. Is the ball still moving up? Is the ball stopped? Is the ball moving down because the defender is, blocking a shot? What exactly is happening? And it's very difficult to understand the motion of the ball based on a still picture. So I'm going to let you guys omit those two. And so let's wrap this up.